So we're going to talk about the properties of a rhombus and a square today. A rhombus is a quadrilateral with 4 congruent sides. That is the definition of a rhombus, a parallelogram with 4 congruent sides. A rhombus is a special parallelogram. All the properties of parallelograms apply to rhombi. Opposite sides are parallel and congruent. So in the diagram, we'll mark an arrow and a slash on the opposite side, and then these two sides are also parallel and congruent. The opposite angles are congruent, which makes this angle congruent to this angle, and this one at the top congruent to the one at the bottom. Angles across from each other. Consecutive angles are supplementary. We've abbreviated that SUPP, which of course means supplementary. You don't have to write that word out if you already know what it means. If I call this figure SHIP, S-H-I-P, what that implies is consecutive angles seem to be evading, like some people don't seem to know what that word means. It means one after the other. So angle S plus angle H equals 180. And I'm not going to write the M's for the measure right now, although that's technically correct. Angle H plus angle I is 180. I'm just going around the ship. Angle I plus angle P is 180. And angle P plus angle S is 180. Okay, so any two, one after the other, are supplementary. Since a rhombus is a parallelogram, the diagonals bisect each other also. It's because that's a property we learned about a parallelogram. So up here, this segment is equal to this segment, and these two segments are equal as well. But different than those, because the diagonals are not congruent. Anybody still need this page? Okay, I'll wait a moment. Okay. Next, in addition, the diagonals of a rhombus are perpendicular. And that, of course, means form right angles. So when you meet, you have right angles. That means you're going to have 4 right angles in the middle there, where the diagonals intersect. Each diagonal of a rhombus also does something else special. It bisects a pair of opposite angles. Okay, well, what does that mean? Well, to us in this diagram, that means that angle DAB up here got cut in half, so these angles would be equal. And since the opposite angles in a parallelogram are congruent, angle DCB got cut in half and was also equal to angle DAB. So these 4 angles here are all the same. And then going the other way, since the opposite angles are congruent, angle ABC is congruent to angle ADC. These got cut in half, but they're different than the ones over here. So we've got 4 angles we put in double arc marks on going this way with that diagonal. It starts to look like we're making designs when we mark these things. There are 2 lines of symmetry to a rhombus, and it happens to be the diagonals. This example is saying that segment AB is 2x plus 6, and that BC is 3x minus 11. What do we know about a rhombus that we just went over that would help us to solve the problem and find x? Okay, Bill? Focus. What do we know about a rhombus? Those are sides, guys. What do we know about the sides? They're congruent. Okay, so this segment's congruent to that segment. It doesn't matter that they're not opposite each other. All the sides are congruent. So BC is congruent to AB. So I'm going to go ahead and set them equal now. 3x minus 11 equals 2x plus 6. We need to subtract 2x from both sides. That gives us x minus 11 is 6. We'll add 11 and find out that x is 17. Okay. The second example, too, says find the measures of each angle, the measure of each angle. The property that we know up here says that that angle and that angle are equal and they're bisected. So what can I do with the 50? If that's 50, then this is 50. What about these two? They're going to be the same. So these would be 50. Angles 2 and 3 are both 50. Following that, also up here, what would angle 4 be? I mean, angle 1, I meant to say. 90. Diagonals are perpendicular. Okay, and then we're going to use the fact that you've got little triangles here that are right triangles. If I use that triangle, there's a couple of ways I can find angle 4. By using the triangle idea, you've got 180 minus 90 minus 50, and that'll give you angle 4. The other way is that this is 100 up here, and this would be 80 because they're supplementary. Consecutive angles are supplementary, and 80 divided by 2 is 4. So I don't care how you think about it, you need to get 40 for angle 4. This is 40. 180 minus 90 and minus 50. So that's using the triangle angle sum theorem. By the consecutive angles are supplementary. We could have done 180 minus 100, 50 plus 50, and we would have gotten 80, and you could have cut that in half. So this would be 40, this would be 40. All of these are 40. Pardon me? This is 6.5. Yep, 6.5 is on rhombuses and squares. All right, so 6.5 continued. We're talking about squares now. A square is a quadrilateral it's a quadrilateral, but it's a special parallelogram with 4 right angles and 4 congruent sides. Okay, so a square has 4 right angles. Draw that on that box and slash the sides all the same. A rectangle is a special parallelogram. It's a special rectangle because of the 4 right angles, and it's a special rhombus because of the 4 congruent sides. What are the angles that the diagonals make then? What would these angles all be? Yep, they're going to be 90, and that's because it's a rhombus. And a square is even more special than a rhombus in that it's got all the properties of a parallelogram, a rectangle, and a square, and a rhombus. The sides are also all equal. I don't think I needed to mark that for this. Oh, yeah, it said 4 congruent sides. So let's add that on. Okay, and we're going to find out there's even more things to learn about these. All properties of parallelograms. One second. I'll apply. I'm trying to see where I am here. Did you have another? You had okay, this box, this box. I'm going to add a couple things onto here. I got the sides mark congruent, but also don't forget, let's do the double mark on those sides for a second, and I'll tell you why. I wanted to add in here so that you would remember that these are diagonals are bisected, so all these segments are the same inside here. So what we got is a bunch of congruent right isosceles triangles. Now, every one of these triangles is right and isosceles. And that would mean that these base angles are 45 apiece. So in this square, you've got square, you have 4 isosceles right triangles. And they're all congruent to one another. Okay, they're all 45, 45, 90. So these angles are 45. And that's true on every one of those. Okay, so now I'm going to flip to the next section, which is asking us to find some parts. All properties of parallelograms, rectangles, and rhombi apply to squares. MNPQ is a square. AP is 7. Find the following. If that's 7, this is 7, this is 7, and this is 7. Okay, so let's answer some questions. A to Q. A to Q, 7. Angle MNP. The corners are 90. APQ is one of those, and those angles are cut in half. It's half of 90, so these are both 45. So angle APQ is 45 degrees. Length of P to M. P to M is a diagonal, and that would be 7 plus another 7. So it's 14. M to Q. Oh, well, that's not on there. I'm going to call it X. This triangle has sides of 7 and 7 and a right angle there in the middle, and these are 45 each. How can I solve this by something we've done this year to figure out the length of this side right here across from the 90? You remember the name of the theorem? Say it louder. Pythagorean theorem. Yes, Pythagorean theorem. A squared plus B squared equals C squared. So here's how we get MQ. This is your MQ. And this is where A was. So 7 squared plus 7 squared equals X squared. Or you could have that reversed. That's 49 plus 49 equals X squared. 49 plus 49 is 98. Then we take the square root of 98 to get X. All right, now, I don't want that. I'm going to be trying to get you to write this answer differently. We're going to be studying special right triangles in the near future. But what I would like, how many of you are taking Algebra 2 concurrently? Yep, 1, 2, at least 2 or 3 of you, all right? You guys have simplified radicals, I'm sure. Right, so what you break 98 on, you see the 49 plus 49 there? That's 249. So 49 times 2, since that equals 98, we can simplify this into something that doesn't look simpler, but it's called simplifying the radical. The square root of 49 is 7, and I think everybody knows that. And so the answer to this is 7 times the square root of 2. The 2 stays under the radical. All right. So on your answer sheet here, put that this was the square root of 98, which equals the 7 times the square root of 2. P to Q is just another side that's equal to it. So it's all of these sides are going to be 7 root 2, 7 root 2, 7 root 2. So it's going to be 7 times the square root of 2. If you did write square root of 98, I would take it at this time. But I want you to know a pattern. I'm going to be teaching you that if you have a 45, 45, 90, you don't need to write this down now. Whatever these sides are, the legs, if that's 5 and 5, then this is going to be 5 square root of 2. If these are 6, 6, this is going to be 6 root 2. If these are 2 and 2, this is going to be 2 root 2. If these are 3 and 3, it's going to be 3 root 2. There's a pattern. But we'll be practicing that more later on. Okay, the conditions for being a rhombus and a square. If the diagonals of a parallelogram are perpendicular, then it has to be a rhombus. All right, so if you see a diagram and you know that these are 90 degrees meeting at a right angle, if this is occurring, then it's a rhombus. Now, I'm not going to write that on every, that didn't write that very well. So I'll erase. Okay, so what my point is, I'm not going to write this every time, if this, then a rhombus. I'm just going to read them to you, and we'll draw them on the picture. If one diagonal bisects a pair of opposite angles, then it's a rhombus. So if you saw a picture with the diagonal drawn, I'm drawing these very crooked, excuse me. I'll use my tool and make it look better. Okay, if that diagonal was drawn, and on that picture, you could tell that these angles were bisected, that these were congruent to one another, then this would be a rhombus. So you might be given numbers. If that's like, say, 40, 40, 40, 40, you would know it's a rhombus. That wasn't a very good example because those are bigger than 40, but whatever. If one pair of consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. That means that one side after the other. So it could be this one and this one. If you saw those two sides were congruent, then that thing has to be a rhombus. Because opposite sides are congruent in a parallelogram, that would make all 4 sides congruent, making it a rhombus. And the other issue, if a quadrilateral is both a rectangle and a rhombus, then it has to be a square. So all it has to show is you got one right angle. If you have one right angle in a parallelogram, then you have 4. If you have 2 sides consecutively congruent, then this thing could be called a square. I just picked 2 pairs of sides next to each other, equal, and a right angle. That's all it takes, and this has to be a square. I believe that was the end for the ISN. We're going to jump to the packet now. Okay, so after this lesson, you should be able to successfully apply the properties of a rhombus and a square. So we've already looked at these, which are the parallelograms. Yesterday we did rectangles. And today we are looking at the rhombi, or the rhombus, and the square. So we've done all of these. And what I wanted to note for you, or look at this. You see how these are all quads? They're all 4-sided figures? 310. Supposed to go at 310. Yeah, that I always put them up there. Yeah, that's what the memo said. So you know. All right, these figures are the ones we've discussed now, and we're going to be adding them to the properties in the back that I have on the wall. I think sometimes it helps for students to make the connections between the figures by looking at a Venn diagram. You see how all of these in here are parallelograms? This is on your this is in your on your ISN. Is it the front cover? Right? So you have this picture. You don't have to highlight or anything. If you want to, you could. But what the point is looking at where things overlap can help you understand what's what. All the things inside that oval are parallelograms. And then you've got a section that's rectangles. And you've got a section that are rhombi. And there's some overlap. And where those two overlap are the squares. So the point is here's how you can read this. A square is a rhombus. A square is also a rectangle. And a square is also a parallelogram. Guys, please pay attention. Now look over here. Are all the rhombi squares? No. Okay, these are rhombi that are not squares. That's why they're outside of the square section. Now, these are rectangles that are not squares. So don't tell me every rectangle is a square. I've had people do that before. All squares are rectangles, all squares are rhombi, and all squares are parallelograms. Now, a rhombus is a parallelogram. because it's contained in here and here. A rectangle is also a parallelogram. And then there's all these other stuff outside. These things out here are just quadrilaterals, and then we're going to be talking in the future about trapezoids, the different types, and okay, we haven't done those yet. So in the little, we haven't done these guys yet. Okay. I think you have a couple of, do you have all this to fill in? Or do you just have rhombus is a parallelogram with 4 congruent sides? I think this is the top of the worksheet. I'm just going to glance at the worksheet. Oh, yes, you have to fill in that a rhombus is a quadrilateral with 4 congruent sides. All the properties of the parallelogram apply to the rhombus. The opposite sides are parallel and congruent, and opposite angles are congruent. The diagonals bisect each other, and in addition, each diagonal of a rhombus also bisects a pair of opposite angles. Now, I'll add that in just a moment. So first, if we wanted to mark this picture up, opposite sides are congruent. They're all congruent. Okay. Opposite angles are congruent, and the diagonals bisect each other. So I'm going to go double, double, oops, and then triple going this way because this is a rhombus. They're not all the same. And the diagonals are perpendicular. So we got 4 right angles in the middle. And then the diagonals bisect opposite angles. So I'm going to be writing that in that blank in a moment, but I'm going to show it on the picture. These 4 angles are congruent going from down diagonal AC. And then diagonal DB cuts these 4 angles into congruent parts. Or it's actually breaking 2 angles up into 4 parts that are congruent. 2 on each end. I said that kind of goofy. I believe you still have that to fill in that the diagonals of a rhombus also, wait, no, they bisect a pair of opposite angles. Bisect a pair of opposite angles you have to fill in. Good luck in your meet. You're welcome. Who are you playing? Who are you playing? Oh. All right, good luck. Beat them. All right, so here's our example 1. We're supposed to be able to find all the angles if we're given that one's 120. Opposite angles are congruent. Well, they didn't ask me for this angle, but I'm going to put it there anyway. I need some ideas. How can I figure it out now? Angle 1, 2, 3, and 4. They should all be what? Now, maybe not give me the size yet, but you should know that they're all going to be the same size. Okay? All right, please. All right, so I got to figure out what they're going to be. Now, Bryce and Lisa, you both raised your hands. Who wants to? Priscilla, okay. So you said subtract 120 from 180. Yeah, you said it right. You're going to do 180 minus 120. How come? Bryce, what were you thinking? What were you thinking? You were thinking something else? Or the same thing? Same thing he said? Okay. Well, that's good because consecutive angles are supplementary. So if you're going this way, those add up to 180. So you're right. 180 minus 120 is 60. But that's for this whole angle. So what do we got to do to the 60? Excellent. Divide it by 2. Okay. So that means all of these are 30. Every one of them. Okay. So if that's how you were thinking, that works out perfectly. It's not the only way to get it though. Because of the 120, 180 minus 120 is 60. You could divide by 2 to share it between those 2 angles. And then that triangle and that triangle are congruent. So there's another reason why they're both 30. Because these are isosceles triangles. Bing, bing. Okay, whatever way. Each one is, each angle is 30 degrees. All right. If you want to write angle 1 is equal to 30, 2 is equal to 30, 3 is all equal to 30. Next one. All right, so we got a rhombus hanging out here. They're asking us for angle 4, and it says the measure of angle BAC is 32, and that is labeled on the diagram. What's angle 4? If we've been paying attention to these properties, you should know immediately that angle 4, because it's a rhombus, the diagonals are perpendicular. So that's the right angle. 90 degrees. Got to know these properties. All right, next. The measure of angle 1. How am I going to figure it out? Okay, you said subtract from 180. Are you looking at this as a triangle? Perfect. That will do it. Okay, so she said do 180 minus 90 minus 32. Okay, that'll work. That's going to give me 58. What other angle is 58? Because the diagonals bisect opposite angles. Angle 2. All right, 58. And then what's angle 3? Yeah, 32, because these two would be 32 and these two would be 32. Okay, so angle 3 is 32. Actually, easier than parallelograms. Okay, got another rhombus. First thing I know that the angles, these are all 3 separate questions. So we're going to actually have to treat them as if they're totally unrelated. So it's like we're going to do a start over on each picture, on the picture each time. It's got angle ABD is 60. ABD. That's up here. And then it says find the measure of angle BDC. Where's BDC? Yep, it's 60 also. Okay. All right, then it says AE is 8 and to find AC. Well, if AC is the whole diagonal and half of it's 8, then AC is 2 times 8, which is 16. You're right. Now, I didn't write a whole lot of stuff on there because the next one I want is the hardest part. If A to B is 26 and B to D is 20, I can't really put that on there. What could I put on BE instead? If I go BD is 20, what's B to E and E to D? They're 10 apiece. Okay, I'm going to put that on the picture. Find AE. They want me to find this. Well, I know there's a right angle here because the diagonals are perpendicular. So I just found out I've got a right triangle there. I'm going to draw it over here. This is A, B, and E. AB was 26, BE is 10. How can I find AE? And I'm going to put an X on it. Pythagorean theorem again. Okay. I know, everybody's face. X squared plus 10 squared equals 26 squared. Leg squared plus leg squared equals hypotenuse squared. 10 squared is 100. 26 squared is 676. I just have it memorized. Subtract 100. Now I know you guys can push the buttons on the calculator. X squared is 576. And that happens to be a perfect square. We need to take the what? What do we do to get the answer? Square root. All right. And it is 24. All right. So then find AE. AE was 24. What? Oh, wait. Did I need to stay there for a minute? No, not for anybody? Okay. Then I will go forward to number 10. Quadrilateral ABC's rhombus. Find the measure of each angle, or each whatever. Find the measure of CEB. CEB. Oh, this is easy because the diagonals are perpendicular. It's 90 degrees. Find, okay, if the measure of angle CBD, that's up here, is 58, find the measure of angle ACB. Well, I want that one then. And that would be 180 minus 90 minus 58, and that is 32. Okay, keep going. Got another rhombus. It says AE is 3x minus 1. Are you using the same figure over and over? You're having to use the same one over. Is it okay? Are you able to write on there and be able to see anything? All right, A to C is 16. So if A all the way from A to C is 16, how big are each piece? I need to do 16 divided by 2 to get 8. Okay, so this is 8, this is 8. 3x minus 1 equals 8 is our equation. We're going to add 1 and get 9, and then divide by 3 and get 3. Okay, the next one, is this using the same picture still? Okay. I think it might be getting crowded on the picture. All right, if you want to redraw, you could, but let me just help you see where it is. Angle CDB would be here, being 6y. ACB is 2y plus 10. What? Oh, you're right. Poo-pooey. It is ACD. I went to the wrong side. I got my brain. I don't know what happened to me. ACB is up here. This is 2y plus 10. However, it can go here, right? Because these are equal. All right, 2y, and oh, this 6y could go up here. I don't care which one you use, but this is a right triangle. So these angles all add up to 180. So 6y plus 2y plus 10 plus 90 equals 180. I'm going to simplify. 8 times y plus 100 equals 180. Subtract 100 from both sides. 8 times y is 80. Divide by 8. And you've got y is 10. Okay, that was 13. Now, a few things again with the squares. A square is a parallelogram with 4 right angles and 4 congruent sides, and 4 lines of symmetry too. The lines of symmetry, the diagonals we can draw in. Okay, so it's got 4 right angles. These are up 45 apiece because the diagonals bisect those angles. The sides are all congruent. I'm going to double slash all the sides. There are 4 triangles formed by the diagonals, and they are all isosceles right triangles with angles of 45, 45, and 90 degrees. Now, what is the angle in the middle? They're all 90 because the diagonals are perpendicular. So they're all 45, 45 isosceles right triangles. A square is a special parallelogram and rectangle and a rhombus. The properties of parallelograms, rectangle, and rhombi apply to squares. I am going to move on to the next example. (14). You've got P to Q is 3 root 2. This side is 3 times the square root of 2. AP is 3. If A to P is 3, then we know 3 other 3's. 3, 3, 3. What's A to Q? 3. What's the measure of angle MNP, which is a whole corner. That would be 90. Angle APQ is one of the 45s. Remember, these are all 45s, and the corners are cut in half. So APQ is 45 degrees, and P to M is 3 plus 3, so it would be 6. Okay, so far. 18, so you got another square. Find x and the length of each diagonal. If Ln, which is a diagonal, is 5x minus 8, and MP, which is the other diagonal, it's going to be equal to this one, is 2x plus 1. The diagonals are equal. So we would subtract 2x. We'd have 3 times x minus 8 equals 1. Add 8 to both sides, get 3 times x is 9. Divide by 3, and we get x is 3. Now it said find x and the length of each diagonal. They are equal, so L to N and P to M are the same. Plug in 3, and you should get 5 times 3 minus 8 is 7. 15 minus 8 is 7. Or 2 times 3 plus 1, 6 plus 1 is 7. They're both 7. I don't care if you called them MP or L. It doesn't matter if it's PM or MP. Okay, just a little bit more. The conditions for whether they are rectangles, rhombus, or squares are listed again. It's in your ISN and repeated here in the worksheet. So number 19 says, draw a parallelogram that must be a rhombus. Show marks to prove it's a rhombus, and it has to be something besides 4 equal sides. Okay, so if you look at, I'm going to draw a diamond, diamond-y shape, which that's a rhombus. I'm saying it's a rhombus. And I'm going to show markings that would indicate that it has to be. One of the properties would be if the diagonals are perpendicular. So if you drew a picture and showed that, if it's a parallelogram and it has a perpendicular diagonals, then this would be a rhombus. What's another way I could draw it? And I can go this way too. I don't have to make my diamond or my rhombus go that way. They said another way would be if one diagonal bisects a pair of opposite angles. So you could show this diagonal and that these angles are congruent, then it has to be a rhombus. That's not the only way. There's a couple more. Okay, this is just an example of what you might draw. This one says mark this diagram so it's that it is a rectangle and a rhombus. So then we'd have to have a right angle and 2 consecutive congruent sides. That would be good enough. This would have to be a square now. Rectangle and a rhombus has to be a square. And that's just an example. Okay. Now, I have kids who have problems with this stuff, so let's focus on what you can actually call it. I want the most specific name. This is a parallelogram, but that's not the best answer. The best answer is a square. Okay. Yes, it is. It's a square because it's a rhombus and a rectangle. Now, 22. What's the best you can call it? Can you call that a rectangle? No. You have just 2 pair of opposite sides that are parallel. So this is simply a parallelogram. One day we're going to have a quick quiz and ask you to name the shapes by all the names possible. 23, what does this have to be? Can you call it a square? No, but you can call it a rectangle. That's the most specific. You could call it a parallelogram too, but it's most specifically a rectangle. This one is a parallelogram, but what's a better name? 4 equal sides, rhombus. Doesn't have to be a square. The most specific name for this one All I see is parallel sides. So parallelogram. Parallelogram. And then 26, that's all you can call it. It's got 4 sides. You can't even call it a kite, though it looks kind of like one. But we haven't discussed kites. Quadrilateral is the best you can do on that one. It's not a kite because this piece isn't equal to that piece. All right, that's your homework. Thank you for your time. Guys, I probably could add to that wall back there. We're going to need to do that at some point. But let's call it a day.